Welcome. Today we're going to be working on section 7 for day 4, simplifying all types of radicals, including ones with fractions and variables. Okay, so to review, when we are simplifying radicals that also are part of fractions, our first step is we're going to reduce the fraction if it is possible. Second step, if the bottom is not a perfect square, then we're going to multiply it by something to make it a perfect square. And we do this, we're multiplying the bottom by that value and the top. Next, we're going to simplify all square roots. Remember, simplifying all square roots, if it's a perfect square, then we just go to the answer. If it's not a perfect square, we break it into two radicals using that product property. And then finally, we reduce the fraction again if possible. Okay, let's go through an example. So, radical x squared over y to the fourth. Well, first step, we cannot simplify this fraction. We have x's on the tops and we have y's on the bottom. Second step, let's check. Is the denominator a perfect square? It is. Y to the fourth is a perfect square. So then what we're going to do is we're going to rewrite this as square root of x squared over square root of y squared. Then let's see, well, x squared is a perfect square. I can just evaluate this radical. Radical x squared is just x. Well, y is also a perfect square. Oh, whoops, I rewrote this wrong. This was supposed to be y to the fourth right here. Excuse my mistake. Y to the fourth is also a perfect square. Radical y to the fourth is y squared. I evaluated all my radicals. Next, I just have to check and make sure there isn't anything else I need to simplify. This fraction is in simplest form. X over y squared is my final answer. Okay, number 2, radical x squared over y to the fifth. So let's check, is this radical in simplest form? It is. Next step, is the denominator a perfect square? Y to the fifth is not a perfect square. We need to make it a perfect square, so we're going to multiply that y to the fifth times y. So then get a y to the sixth on the bottom, and that's perfect square. Because I multiplied the bottom by y, I also need to multiply the top by y. That goes back to that identity property. I'm multiplying this whole fraction by y over y. Y over y is just 1. It stays the same. So then I'm left with radical x squared y over y to the sixth. And I can split it into two radicals now. So radical x squared y, we'll extend that, over radical y to the sixth. And I can then next, let's see, use the product property, split the top into two different radicals. And I'm going to evaluate all these radicals. Radical x squared, that's a perfect square, that's just x. Radical y, it's not a perfect square, I can leave it. Radical y to the sixth, that's a perfect square, that's y cubed. Now all I need to do now is just check, make sure that I am in simplest form, and I am. There's my final answer. Okay. 18 over x cubed. My first step, I'm going to see if I can simplify this fraction at all. I can't. Then I need to check my denominator. Is it a perfect square? It is not a perfect square. X cubed isn't a perfect square. I want to make it a perfect square. I'm going to multiply by x. I'm also going to multiply the top by x. Have to do the same thing that I do to the top as I do to the bottom. So then I'm left with the following: radical 18 x over x to the fourth. I can split it up using the product property, left with radical 18 times radical x over radical x to the fourth. Now I can evaluate each of these radicals. Well, first of all, I need to look. Radical 18, well, that's not a perfect square. Let's go back, think what we were doing earlier this week. We can split radical 18 into the product of radical 9 and radical 2 times radical x over radical x to the fourth. That's because we need to think back. Well, 18 is the same as 9 times 2. Now 9 is going to be our greatest perfect square. You could also figure that out again by making a list of all the factors. I'm not going to go through all of them, but right here, 9, that's going to be our greatest. We split 18 into 9 times 2, and then we can use a product property to split that into radical 9 times radical 2. Now I can just evaluate. So let's see, radical 9 is 3. Radical 2 is not a perfect square. We leave it. Radical x, not a perfect square. All over, well, radical x to the fourth, that is x squared. My last step is I'm going to combine these two radicals right here. So my final answer is 3 times radical 2x, using the product property, all over x squared. Whoops. Okay, I want you to try number D on your own. Pause this video and we'll talk about it in a moment. Okay, let's talk about number D. First thing, you can't reduce this fraction at all. I can't simplify it. Next, I'm going to multiply by D. Oh, whoops. I need my pen. I'm going to multiply by D on the top and on the bottom. So my bottom becomes a perfect square. Now, since 4 is a perfect square, I don't need to multiply by any constants, but d to the fifth isn't a perfect square. That's why I'm just multiplying by d. And that is then equal to radical of 5 c to the fifth d over 4 d to the sixth. Next up is I'm going to, whoops, I don't need that. I'm going to split this whole entire section into split these all into its own little radicals. So radical 5 using the product property times radical c to the fifth times radical d all over radical 4 times radical d to the sixth. Now I can evaluate each of these radical 5s. Well, radical 5, that's just going to be radical 5. It doesn't have a greatest perfect square. It doesn't have any factors that are perfect squares. Let's see. Well, if I take a second and look at c to the fifth, well, I can split that up into c to the fourth times c. I'm just going to copy down everything I have left. Radical d over radical 4 times radical d to the sixth. Well, again, now I can totally evaluate each of these radicals. As I said earlier, radical 5, that's just radical 5. Radical c to the fourth, that's radical c to the fourth times radical c times radical d all over radical 4 times radical d to the sixth. Evaluating each of these radicals, I'm left with radical 5 times, let's see, c to the radical c to the fourth, well, that's just c squared times radical c times radical d all over radical 4, well, that's 2. Radical d to the sixth, that's just d cubed. Now, my one final step is I'm just going to rewrite this. I'm going to write my final answer over here, but I'm going to combine my terms. So I'm going to combine everything in my radicals, this 5 and this c and d, and that c squared is going to stay up front. So c squared radical 5 cd all over 2 d cubed. My final step would be just to check to see if I can simplify this fraction at all, and I can't, so that's my final answer. Okay, 11y cubed all over 27. Now my first step is to look at, is 27 a perfect square? Oh, whoops. Is 27 a perfect square? Well, it's, let's see, not a perfect square. How do I make it a perfect square? Well, one thing that I do for this is I know that 27 is the same as 3 cubed. Well, if I multiply it by another 3, that would be 3 to the 4th, which is a perfect square, which is equal to 81. So I'm going to multiply 27 by 3, meaning I'm also going to multiply the numerator by 3, which gives me 33y cubed all over 81. That's the radical of all that. Next step, I am going to use the product property, break it up into radicals. So I have radical of 33 times the radical of y cubed all over radical of 81. Well, if I look at this y cubed, I can break that into break those into two radicals. So I'm left with radical 33 times radical y squared times radical y all over radical 81. Let's see, 33 I can't break into any radicals. It does not have a perfect square factor. So now I'm just going to evaluate each of these radicals. I'm left with radical 33 times, let's see, radical y squared is just y times radical y all over radical 81, that's 9. Now I'm going to rewrite it. I'm going to group my terms. My two radicals I'm going to combine. So I'm left with a y times radical of 33y over 81. Last step, or sorry, excuse me, all over 9. Last step, I'm just going to check, make sure that it's in simplest form. It is. So that's my final answer. Okay, radical 9ab over 4ab. So first step, I'm going to check if there's anything to simplify. Let's see, I can cancel off, let's see, I need to change to the pen. I can cancel off the a's. I can also cancel off one of the b's. So this leaves me with radical 9 over 4b squared. My next step is I'm going to check to see if my bottom is a perfect square. 4b squared is in fact a perfect square. 4 is a perfect square. B squared is a perfect square. So I'm just going to start dividing it into radicals. Or breaking into radicals. So I'm left with radical 9 over radical 4, radical b squared. Let's see. When I evaluate those radicals, I'm left with 3 over 2b. I check and make sure this is in simplest form. I can't reduce this fraction at all. That is my final answer. Okay, 2 left. Radical 5x cubed over 3n to the 5th. First step, can I reduce this fraction at all right here? I can't. My next step is I want to make 3n to the 5th. Let's see. Whoops, there we go. 3n to the 5th, a perfect square. To do that, let's see, 3 isn't a perfect square, but I can make it a perfect square by multiplying by 3. N to the 5th isn't a perfect square, but I can make it a perfect square by multiplying by n. I'm going to do the same to the top. So I'm left with the following, whoops, I wrote that kind of close. I'm left with the following radical. Let's see, 5 times 3 is 15, so 15 x cubed n all over 9n to the 6th. I'm going to start breaking into radicals. So this is the same as radical 15 times radical x cubed times radical n over radical 9 times radical n to the 6th. I'm going to scan. I'm going to see if I can break this into any more radicals. Well, radical 15 does not have any perfect square factors. You could do this by checking and writing out all the factors, which is 1, 3, 5, and 15. Well, x cubed does have a perfect square factor. X squared times x squared is a perfect square factor, so I'm going to rewrite this as radical 15 times, well, radical x cubed is the same as a radical x squared times a radical x. We have that radical 9, or radical n, all over radical 9 times radical n to the 6th. Let's see, now I'm going to evaluate each of them. So radical 15 is just radical 15. Radical x squared is x times radical x times radical n. Then let's see, all over radical 9 is 3. Radical n to the 6th is, is just n to the 3rd. Last step, I'm just going to rearrange it. In my numerator, I have an x up front times radical 15xn. We write that all in the same radical, all over 3n cubed. One final check, make sure I'm in simplest form. I am. Here's my final answer. Okay, I want you to do the last one, D, on your own. Pause this video, take some time to work. We'll go over it in a minute. Okay, let's start going over D. First step is to simplify this fraction if it isn't simplified already. Well, I have a y right here. I can cancel out one of the y's. Let's see. I have x to the 5x on top, 2 x's here. I can cancel out 2 of the x's. So this becomes a 3. And 9/12, well, the fraction 9/12 is the same as the fraction 3/4. So I can rewrite these constants as 3 over 4. So let's just rewrite this whole thing in simplest form quickly. Radical 3x cubed over radical 4y to the 5th. Now I need to check, is my denominator a perfect square? Well, 4 is a perfect square. Y to the 5th isn't. So I'm going to multiply the top and the bottom by y. So then I'm left with radical 3x cubed y over radical 4y to the 6th. Now y to the 6th is a perfect square. I am going to next divide this into radicals. So radical 3 times radical x cubed times radical y all over radical 4 times radical y to the 6th. I'm going to just check each of my radicals I have right now and see if I can break it into 2 radicals. Well, I can't break 3 into 2 radicals, but I can break x cubed into 2 radicals. So now I'm going to rewrite this as radical 3 times, if I can break x cubed into x squared times x, where x squared is a perfect square. So this is the same as, whoops, that's supposed to be a 2. It kind of looks like a 4. I apologize. That's radical 3 times radical x squared times radical x times radical y all over radical 4 times radical y to the 6th. So let's see, now I'm going to evaluate radical